Hey there, my name is Steven, and in this video I'm going to show you how to set up your LumenPnP v3 with OpenPnP. If you run into issues throughout this process, feel free to shoot us an email at support@opula.io or fill out the form on our website and we'll be happy to help you out. OpenPnP is a huge piece of software, and this is meant to get you up and running to the point where you can actually be populating boards. There's still a lot more that you can do in OpenPnP, so there's more that you can explore and dive into, but this is what you need to do to actually get going and using your LumenPnP. This video is an auxiliary to our documentation site, which is docs.opula.io, so check that out and you can follow along with that documentation along with this video. This setup is for a v3 machine. I'm using OpenPnP configs from the v3.0.2 release. And we're using the OpenPnP version that was released on August 1st, 2022. This is the full version number right here. All right, so first up is your physical setup. You should have just finished putting together your LumenPnP and now you're ready to get it all set up for your first job and plug it into your computer. This is generally what your setup should look like. Go ahead and download OpenPnP. We're going to import the default configuration that we provide to get you as close as possible to a fully calibrated machine. So you can go ahead and download those. And instructions for doing all of this is on docs.opula.io, so you can see how to do it for your platform and get them all imported properly. And then once you have those files imported, you can go ahead and open OpenPnP. You might find that when you open OpenPnP, it throws some error about something that it's not able to find in your configuration. If you find this, make sure that you are using the config that's in the v3.0.2 release, and also that you're using this version of OpenPnP because these two are known to work together. Now we're going to connect your machine to your computer. I'm connecting mine to a 2021 MacBook Pro, and I need to connect 3 wires into my computer, 2 USB webcams and 1 USB port for the serial communication with the controller. Now, depending on your computer's hardware, you may have a hard time getting both of the webcam feeds to go through one USB hub, or even one USB port through a really good hub, but the internal USB hub on your computer isn't able to handle the throughput of 2 HD webcam feeds. You might need to test which ports you should be plugging your USB cameras into that can handle the bandwidth. We use Lenovo ThinkPads and they work quite well for us, and they're able to handle the throughput through 3 separate USB ports directly into the computer. My Mac is able to handle both webcam feeds and USB through 1 port. So I just have 1 USB-C connection that goes into my Mac, and then the 3 USB ports go into the hub. And this works out for my computer, but your mileage may vary. But before I plug this into my computer, I'm going to turn the power on to the machine. When you plug power into your machine, you should see that the lights flash red, green, and blue and then go full white. That means that Marlon has booted properly and you're all set to connect it to your computer. It's really good to plug in power into the motherboard first and then plug it into USB. If you plug it in first, sometimes this means that communication with the stepper motor drivers doesn't communicate properly and you can get incorrect speeds with your machine. So if you see that your machine is trying to move really fast or skipping steps, it's probably because of this. So make sure that you plug power in first through the barrel jack before you plug it into your computer over USB. Alternatively, after you plug everything in, you can just hit the reset button on the motherboard and that'll do the same thing. Great, so your machine should be connected to your computer. Now we're gonna go ahead and open OpenPnP. All right, so when you boot OpenPnP, this is about what you should see. You'll see the 2 cameras on the left side, which show the top and bottom. Beneath that is your machine controls, which lets you jog the machine around. It lets you do some special actions like discard a part that's currently on the nozzle and recycle it back into the feeder, which is pretty cool. In actuators, this lets you manually control things that we've set up specifically for you, like turning on the LEDs or controlling the vacuum pumps. Something really important to be aware of in OpenPnP is this dropdown, which is actually telling OpenPnP what you want to control when you're jogging things, among other things inside the whole UI of OpenPnP. So this N1, when I have nozzle 1 selected and I jog Z up and down, it will jog the first nozzle up and down correctly. But if I were to try and jog up and down looking at the second nozzle, it would be backwards. So go ahead and select the second nozzle if that's the one you want to jog. If you find that you're trying to jog Z up or down or do some operations, look and see what you're actually controlling here, and that might be your problem. For example, if you select camera and you try and jog Z up and down, nothing will happen because the camera you can't adjust the Z of the camera. So just be aware that this is a thing in case you're running into jogging problems or things aren't moving like you expect. All right, so the first thing we're going to do is make sure that OpenPnP knows what USB ports it needs to be talking to our 2 cameras and to the controller. So the first thing I'm going to do is go into machine setup, and this is going to show me all of the different components of the pick and place. You can click this expand button and it will show you all of the details I do this sometimes, but honestly, I think a lot of the times it shows stuff that isn't necessary. So first what I'm going to do is I'm going to go under drivers and I'm going to select G-code driver. And this is where we're going to pick the USB port to talk back to our motherboard. So what I see here in under port, this is where we're going to select the port. This is the default value that comes with the config. This doesn't mean that this is actually what your computer is seeing. If you click the drop down, you'll see maybe there are some other options. So here I have CU, USB modem, 30, 80, etc., etc. This is what my Mac sees when it's looking for the USB port. If you're on Windows, you'll probably see something like COM1 or COM2. And if you're on Linux, you'll probably see TTY ACM0 or something along those lines. So I'm going to go ahead and select one of the ports here. On Mac, I can connect to either one, but some people have told me that they only have success connecting with CU, and this has to do with the Mac drivers. So once I have that, I'm going to make sure I hit apply in the bottom right corner. This is super important, and if you don't click this, OpenPnP does not respect any changes that you make. So every time you make a setting change, it's very important to hit apply. So I'm going to go ahead and hit apply, and now I'm going to try and connect to my machine, and that can happen with this little power button over here in the bottom left. So I'm going to click that and wait for a second, and then if I see, there we go, that means I've connected. If I get a little yellow house icon and a red disconnect button, it means I've connected to the controller. We are not connected to the cameras, however, so that's what we're gonna fix next. The first thing we're gonna do is connect to the bottom camera. So I'm gonna go here under cameras, and I'll see OpenPnP capture camera bottom. So I'm gonna click on that, and then that will give me the settings for that camera beneath down here. Now I'm going to click on device settings, and this is gonna let me choose this camera. And then next to device, I'm gonna click the drop down and I can see some options here. So here's FaceTime HD camera. This is the one built into my Mac that you're looking at me through right now. And then I have PNP top camera and OpenPnP bottom camera. Due to a bug with the way that USB drivers work either across Windows or Mac, sometimes these names are not consistent. A lot of operating systems will try and think that they know what the actual name of the device is if they've seen that device ID before. And this isn't necessarily true, so you might find some inconsistencies with this naming, but effectively one of these cameras is going to be your top and one of them is going to be the bottom. The names should be PNP top camera and PNP bottom camera, but you might see variation depending on your operating system and what other cameras you've connected to your computer before that have this same device ID. So I have camera bottom here, so I'm going to select this one, and I'm also going to change my format to be 1280 by 720 at 10 FPS. Now this is just because I am on a Mac. You might find that you have a different option if you're on Windows or Linux. In general, you're gonna wanna select the one that is 1280 by 720. If you have an HD version at 1080p, don't bother selecting it, it's really not worth it. And then keep it at 10 FPS. There's really no need to go any faster than that. So select your equivalent on your operating system as the 1280 by 720 at 10 FPS, and then you can go ahead and hit apply. Now you should see something pops in your bottom camera feed. You might also see that it's still jet black, and that's totally okay. If you just see this X go away in the gray box, you've connected to the camera properly. We're going to address if the color looks weird or it's very hard to see. We'll address that in a later step. So now we're going to do the same thing for the top camera, but for some reason OpenPnP does not put the top camera next to cameras. It's actually hidden underneath heads. So I'm going to click the drop down next to heads. I'm going to click the drop down next to reference head, and then cameras here has OpenPnP capture camera top. So I'm going to do the same process here. I'm going to select under device settings. Under my device, I'm going to select PNP top camera, and I'm going to do the same thing before where I'm going to pick a 10 FPS or a nice low FPS setting that has at least 720p. And then we're going to hit apply. And there's our top camera view. So now I can actually move my hand over these, and you can see the frame rate's really low, but that's totally okay. We don't want to bog it down too much with a high frame rate. And there is my hand pulling in the live feeds of both cameras at the same time. So now we are fully connected. If you have problems connecting to your camera or you see it show up and you try and connect and it doesn't connect, try using a different USB port on your computer, using a different hub. Sometimes it can be tricky to connect these, and it's all because the hardware inside of a computer, inside of your computer, the USB hub sometimes can't handle the throughput. If you have problems with this, please don't hesitate to reach out to us at support@Opulo or our support form on our website. All right, awesome. So we are all set to go. We are connected, we have our cameras dialed in. Now we're gonna start going through the calibration process. All right, so the very first thing we're going to do is home the machine. When OpenPnP sends a homing command to the machine, not only does it send the normal G28 G-code command to the controller, but it also moves the head over what we call the homing fiducial on the datum board right above your camera. So before we hit the home button, make sure that both of the heads on your machine are an equal height to make sure that when it moves across, it's not going to collide with anything in the machine. So mine look pretty nice and level, so I'm going to go ahead and hit the home button here. And it's going to move the head to the front left of the machine. If you find that when you click the home button and the machine starts to move, it doesn't move all the way to the front left, it might stop a little early. That might be because the sensitivity for the sensorless homing might be set just a little bit too high for your machine. It homes using a sensorless homing, it doesn't have a limit switch, so it's all based on current. There's a couple things that you can do. You can either loosen some of the tension on the gantry just a little bit to make it a little easier to move, and then it won't trigger it too early, or you can change the setting in your machine for how sensitive the homing should be. If you find that it's triggering too early, you can tune this with the M914 setting. It's very easy to tweak this if this doesn't quite work the way you expect. The default settings for the sensitivity on homing are 60 for the x-axis and 50 for the y. And you can check this by going to your G-code driver under machine setup, hit console, and type in M914 like this, and you'll see that it will tell you what the sensitivity is. You can change this by typing M914 and then putting in X and then your new value, or Y and the new value, to change what the sensitivity is. The higher the number, the more sensitive it will be, and the lower the number, the least sensitive it will be. So if you're finding that it's triggering early, you're going to want to bring the value down just a little bit. Just bring it down 10 at a time until you see that it works successfully. So I'm going to go ahead and I'm going to bring my X sensitivity down just to 50. So I'm going to type M914 X50 and hit send. And then I can check and make sure that worked properly by just sending M914 again. And I can see, sure enough, X homing sensitivity is now 50. And then I can try homing. And then if that works correctly and it moves all the way to the front left of the machine, we can save these settings by going into G-code driver and then G-code. And then under head mountable, you're going to want to select default. And under setting, you're going to want to select connect command. And these are G-code commands that run on boot when you first connect to your machine. We're going to add a new row here, which is going to be M914. This is exactly what we just typed in a second ago, X50. And then hit apply. And now every time we connect to the machine, it will set this so that your homing should work correctly. I'm going to go ahead and hit the home button here, and it's going to move the head to the front left of the machine. And then it's going to home the Z, and then it's going to move the head over to the homing fiducial. And here we can see the homing fiducial appearing in the top camera. It's this little Opulo logo with a dot in the center, and we're getting an error, fiducial home, no matches found. This is totally okay. So I'm going to go ahead and hit OK. So now what you're going to do is jog your head to the center of the homing fiducial. Now you can see here, this is what's called a reticle across the view here on the camera. If you want to change it, you can right click. And under reticle, you can change it from fiducial to grid or ruler or crosshair. I'm fond of the fiducial, so that's what I leave it on. And there's a couple ways you can actually jog the head around. You can either go down here to your machine controls and set your distance to 1 millimeter or something along those lines, and click the arrows and move yourself over to the dot. What I prefer to do is you can actually click and drag around here in the camera feed, and it will just jog to where you're trying to go, which is pretty cool. So I'm going to try and jog to the center here. You can scroll in and get even more precise. And here, now that I'm getting really precise, I'm not going to click in the camera. I'm just going to bring it down here to a really small increment, and I'm just going to jog it over just a little iota to get it as close to center as I can. Great, that looks fantastic. So now that we're nice and centered, what we're going to do is we're going to capture this position and tell the machine this is where your homing fiducial is. The way that we're going to do that is we're going to go to reference head under heads, and this is all still under machine setup. And you'll see here homing fiducial. We're going to click this little blue button here, and what this does is when it is next to a field in LumenPnP, so you can see this X and Y, wherever the camera center point is, which you can see from the reticle here, it will take that position and put it into these fields. So I'm going to click this blue here, and you can see it'll say capture the location that the camera is centered on. And when I click it, it's going to update these two positions in here. And I'm going to hit apply to make sure it saves. So this is fantastic. Now I actually have the center point for my homing fiducial. And you can see even if I jog away from it, I can click this button, which will move the camera to that position, and it'll move it right there. This dot is really important because when we home to the front left of the machine, it's really imprecise inherently. It's not nearly precise enough for picking and placing components. So after we home there to get a broad idea of where we are, we move the head over to this dot to get a really precise idea of where it is. And because of this, if you ever move your datum board after you do this step, all of your other calibration is going to be affected by that. So that's why we do this step first and get this set up, and why it's also important you don't move your datum board after you get this all set up. Okay, so before we adjust the vision pipeline for actually finding this dot, we need to make sure that our camera exposure is set exactly how we want to keep it for the rest of our time using this machine. For some reason, OpenPnP does not remember these settings once you set them. So it's really helpful to write them down and be aware of them and make sure that you set them every time on boot, because unfortunately they do not remember that between boot instances. First, we're going to adjust the exposure for the top camera. Again, that is under Heads, Cameras, OpenPnP Capture Camera Top. And then under Device Settings, you should see Properties. And these are all these different variables that you can tweak to change the settings in the camera. OpenPnP has not implemented this working well on Mac, but you should see this on Windows and Linux. It will only make some of these settings lightened up if it's actually able to communicate those with the camera. We picked a camera that does have the ability to communicate over what's called UVC, which lets you set these settings, but OpenPnP does not support this for Mac for some reason. I find that the auto exposure on the cameras is okay enough for me running this with a Mac, but if you'd like to set them manually, there is an application that we recommend in our docs page that lets you manually control it outside of OpenPnP, so there's a link for that at docs.opulo.io. When setting your exposure, if you're on Windows or Linux, setting this exposure should make it look just about like this. You don't want it to be super bright and blown out, but you also don't want it to be very dim. You want to be able to see the white parts, the highly reflective parts, which should come through as almost perfectly white, but then everything else should look maybe just a little bit darker, especially the matte black solder mask around here. Once you set these settings, I highly recommend writing them down and making sure that you keep them by standard. When OpenPnP boots, it really likes to put things into auto exposure, auto modes with the cameras. A way to disable this is to check auto and then uncheck auto. Even though it is unchecked when you first go into OpenPnP, it might still be in auto mode, and the way to clear that out is to click the checkbox and then uncheck it again, and that will send the command to the camera to not have it set for auto, and then you should be able to drag these values to set the appropriate exposure or contrast or brightness. After you've picked this, keep this for that camera. It's really important that you keep this consistent because all the vision pipeline tuning that we're about to do is going to be based on these exposure settings. So make sure that once you set this, you're aware of what they are and you have them set for both the top and bottom cameras. Ultimately, a lot of what's going to happen is going to depend on the vision pipeline. So as long as it looks relatively similar to what you see here on my two feeds, it's going to be totally fine, and we can do the rest of the cal in the vision pipeline. It's just important that this is consistent and you can tell what's going on in the picture more than anything. That's really what's important. While we're here working on the cameras and setting exposure, we're going to set the pixels per millimeter as well. So go ahead and jog to the homing fiducial position that you set, and you're going to jog up so you can see one of these squares that is isolated around here, right next to the homing fiducial. And we're going to start with the top camera. So reference head, cameras, camera top. You're going to go under general configuration and then scroll down to units per pixel. What we're going to do is under object dimensions, we're going to put in 5 for both X and Y, and then you can go ahead and hit measure. And now what you're going to see is this little adjustable box is going to appear in the camera area. And what we're going to do is we're going to align this as perfectly as we can along the center line of this box. And this is going to tell OpenPnP what dimensions a pixel is. How many millimeters does a pixel represent, which is a really important thing for us to know as we use this for populating circuit boards. So I have mine set here as close as I can get it to the center of these lines. I'm going to go ahead and hit confirm, and I'll see that new values populate in here for units per pixel, and then I'm going to hit apply, and I'm going to save my configuration. Now we're going to do the same thing for the bottom camera. You can go ahead and take an N24 nozzle tip and put it onto one of your nozzles. It doesn't matter which one as long as you can get it centered over the bottom camera. Also, if you have not done this already, take some of the lube, the super lube packet in your toolkit and lubricate the end of the CP40 holder, the brass tip, before you start putting the nozzle tips on. And then work it in and out a little bit just to lubricate the whole process and make sure that the gaskets, the O-rings that are around the brass CP40 holder are going to slide in and out nice and easy. So now we're going to set pixels per millimeter for the bottom camera. I am just going to jog the head over the bottom camera so that it is in view. And there we go, it's pretty close. And I can do the same thing with the bottom camera that I can on the top of clicking and dragging to what I want to center. You can see it didn't go quite perfectly to the center there. That's actually because the pixels per millimeters needs to be calibrated. Cool, so now I have my nozzle tip here visible. And we're gonna do the same thing that we just did for the top camera, except we're going to do it for the bottom. So under cameras, select the bottom camera, and under general configuration, go and for object dimensions, you can put in 4 millimeters for each one, because that is the size of this nozzle tip. And then we're gonna hit measure again. And then you can adjust this draggable box to perfectly fit around this nozzle tip. You can use your finger to find out what the actual diameter of the nozzle tip is. I'm putting it right along the side of the nozzle tip, and you can see that this line right here is actually the edge. So I'm going to make sure that it fits nice and neat. We do have default settings in for this, so it should be pretty close what you get out of this to what comes default in the box. But it's always good to do this just a little bit more precise. It makes things a little bit smoother. So now after we have it selected around here, I'm gonna hit the confirm button. You should see that those numbers change just a little bit, and then hit apply and save your configuration. All right, so because we were having a hard time finding the dot, the fiducial home, we have to edit the vision pipeline to actually get it to find it correctly. So first what we're gonna do is we're gonna make sure that our reticle is centered over it as best as we can make it, and at least get it somewhere close. It doesn't have to be perfect, and it probably won't be because the homing, the dead reckoning from the home position in the front left of the machine won't be perfect. And then we're going to go to Vision, and then under this drop down here in the upper right, select Fiducial Vision, and then click on Default Machine Fiducial Locator. And this is the vision pipeline that we use for finding the fiducial. Underneath this fiducial vision settings, you can hit Edit next to Pipeline, and that's where we're actually gonna edit how OpenPnP looks for this dot. So I'm gonna hit edit, and it's gonna bring up this window for me, and this is editing the vision pipeline. There are a lot of different stages in here, and all of these are things that we write a lot about on docs.opula.io, so go check that out if you want an in-depth about all of this stuff. But I'm gonna show you how I go through and debug a vision pipeline to get it so it's gonna find this dot correctly. I like using the detect circles hoe method. A lot of other folks use a circular symmetry, which I've heard works wonderfully, and I've used it before and I do like it quite a bit. So know that there's even a couple different ways to go about doing this, but this is just the method that I like to use. So we're gonna start clicking on some of these stages is what they're called, and the image on the right is going to show what that stage has done to the picture. So it'll take the picture, it's going to convert it into gray, black and white, because we don't really need color for this. And then we're gonna mask out a circle, which means if we find other stuff in the picture around here that might look like a circle, we don't want it to find it. We know it's gonna be within some range pretty close to the center. So we mask out a circle. You wanna make sure in this stage that it's actually keeping all of the fiducial inside of this ring, because if not, it's not gonna find it correctly. And then threshold, and threshold is a really important step. This takes all values brighter than a certain value and makes them full white, and all values darker than a certain value and makes them full black. There's no grayscale anymore. So if I click on threshold, I see it's just all white. It's just a full white sheet. And if I look over here, my threshold is actually set very low, all the way to 2. This is a range from 0 to 255. So I'm gonna try and put in 100 and click away from it, and it should update the picture. Now I can see what I'm finding here. And now I can kind of start to see a little bit of clearing away of some of this white, but it's still not that clean. I'm not getting a nice clean white isolated circle. So I'm gonna bump this up even more. Let's try 150 and see what this looks like. 150 is pretty good. Now this masked area off around here where it's just, there's no copper, there's no solder mask, it's just the FR4. This does look dark and we have a nice white ring, but there's still a couple little greeblies hanging around. So I'm gonna try and even bump this up to 200 and see what I get from this. All right, this is looking pretty good. I'm starting to lose a little bit of the white inside the fiducial, but that's okay. It's still gonna be able to find this circle pretty well anyway. I highly recommend not setting the auto tag, because this will automatically tweak the threshold based on what it thinks makes the most sense, and I find that it's really not that great of a solution. And then we're gonna go down to detect circles hoe, and this is actually the step that finds the circle around here somewhere. But it can be kind of hard to see if it's doing what it's supposed to if we can't actually see the circle that it's finding. You can see down here, we're actually getting a response value. It's centered at 644 and 367 and a diameter of about 70. That's the circle it's finding, but we can't see it, so it's hard to figure out what's actually going on. There's a great way that we can still see what's going on and debug this step by going down to draw circles right here, this stage called draw circles, and you can see it's actually drawing the circle that it's finding right here on the picture. If we go up here to this pin button, it just keeps this image here no matter what stage we're in, so we can see how editing a certain stage will change this picture. So now I'm gonna go back to detect circles hoe, and I'm gonna start tweaking some of my values here. So in this example, I can see that there's no red circle being drawn on my fiducial, which means I have some problem where I'm not actually finding it. It looks like my threshold setting looks pretty good. I'm gonna unpin this just to look at my threshold. It does look like I have a pretty good, well-defined circle, so that's great. But I'm not quite sure why I'm not able to find the circle. So what I'm gonna do is I'm gonna start looking through some of my settings here, and there's really 3 big ones that you're gonna wanna address in this stage. Minimum diameter and maximum diameter are very important because they only allow circles that have a diameter within these two. So one of the first things I'll do if I'm not getting any response at all is I'll set this very, very low, 20, and I'll set the max very, very high, let's say 200. And you can see already I'm starting to get some circles coming through here. And there we go. Now we have 3 or 4 circles. So we are starting to detect them, but there's too many. And also there are ones that are way smaller and not any that are much bigger. But I do want to bring this, filter this down to just about the right diameter. So now I'm going to unpin this picture and I'm going to look and see actually what are the diameters that I'm finding here of the circles that are actually showing up. So the absolute smallest one is definitely the 43 and the 51, but then I'm finding 2 that are about the right diameter that are 50 or 70 and 72. So I'm going to try and center my diameters to be around that. So I'm going to set my max to about 80, and I'm going to set my minimum to 60. And now I can see it's finding just one circle with a diameter of about 71.5. And if I go back to draw circles, I'll see, sure enough, it is putting it exactly where I want it to be. So this diameter trick, making it really wide and then figuring out which one you want, can really help you find out what diameter you're looking for the Fiducial. It should be about 71 in diameter for you as well, because you have the same camera that I'm using for this example on a standard Lumen V3. Another parameter you might want to edit is param2, and this number is going to change how sensitive it is to detecting a circle. If I bring this all the way down to 1, it's going to be very, very inclined to find circles all over the place when we really don't want them. But if I also make it 100, it's really going to be picky, and it's probably not going to find a circle unless it's perfect. So we keep it at around 10, but this is a great thing to know that if it's not quite sensitive enough to find a circle, you can tweak this parameter and it should find it okay. Great, so now I have a really nicely tuned pipeline. So I'm going to hit an X to cancel out of this, and then it will prompt me to save changes, so I'll say yes. And now I'm going to go back to machine setup, and to my reference head, I'm going to select visual home, and this is just going to do the homing process on the Fiducial. So I'm going to hit visual home, and we'll check and make sure enough, there it's finding the red circle, and it's slowly centering itself on that point to find exact dead center and put the reticle right over the homing Fiducial. Okay, so now with our homing Fiducial position set, our exposure set on our cameras, and our vision pipeline set, we're going to go ahead and try and home one more time, and we're going to see what happens. All right, my head's moving over to the homing Fiducial, and you can see it finds the Fiducial, and it'll run a couple times to try and find it and really get it dialed in. And then it's going to try and find my nozzle tips. So it'll move the nozzle tip over the bottom camera on the first head, and then it'll do the same thing on the second head. And you will very likely also get an error on this as well, because there's some setup that we have to do to get this to work correctly. So you can go ahead and clear out of these errors, and now we are going to set the nozzle tip position. This is telling LumenPnP how far away each nozzle is from the top camera. LumenPnP makes this pretty easy using a little wizard to make sure that this is set correctly. So first we're going to start with the left nozzle, or the N1. This is the one facing the left side of the machine. So what we're going to do first is we're going to go under heads, reference head, nozzles, select N1. And then underneath the settings here, select offset wizard. Make sure that include Z is unchecked. And now what we're going to do is we're going to jog the nozzle tip to the center of the homing Fiducial. This is a reference point that we can use to tie the top camera and the nozzle tip together to make sure that they are on the same offset. They're in the same, working off the same plane of coordination. I'm going to manually jog my head over to the homing Fiducial, and because I'm on N1, I'm going to make sure that I select nozzle N1 here, and I have an N045 loaded on this. And I'm going to move my distance down to just 1 millimeter, and I'm going to jog the Z down, and I'm going to jog it so that it is centered on the homing Fiducial. You're really going to want to get down nice and precise. I suggest going even all the way down to the 10 micron distance, and make sure that you cannot see any of the homing Fiducial anymore. This is why I like the N045 nozzle for this, because it actually perfectly covers the gold. So if you see any gold peeking out, you know it's not perfectly centered. Great. When it is perfectly centered, you're going to want to go ahead and click Store Nozzle Mark Position. And this is going to just capture the nozzle tip position. Now what we're going to do is we're going to jog the head back up, and then we're going to jog over to put the camera over the homing Fiducial again. And now we can jog right over to it. Now, you might be tempted to actually go and when you click on reference head, it will let you jog to the Fiducial position. Don't do this, because this will actually wipe out the nozzle mark position that you've grabbed. So you should just manually jog over to it. I'm going to jog over just a little bit, get nice and centered. And then I'm going to hit calculate nozzle offset. And this is going to do a little bit of math. You should see some new numbers popping in here. This is calculating what's the actual offset of the nozzle tip. And then you can go ahead and hit apply. And now we're going to do the exact same thing for the other nozzle. I suggest putting the N045 nozzle tip on the N2 head, the right head, and then just doing the same process, doing the offset, putting it over the homing fiducial, and then jogging it up and putting the camera there, and then calculating the offset. It shouldn't be too far off from the default values. They should get you very, very close. But getting this precise is really what's going to help make your placements very accurate. All right, now that we know where our nozzle tips are in space, we can set the bottom camera position. What we're going to do is we're going to scroll down to cameras and then LumenPnP capture camera bottom, and then go to the position tab. So what I like to do for this is I will select one of my nozzle tips, the N045. This is my N1 right now. And this position in here, this location for the camera is pretty close to what it should be. So I'm going to click this button, which is going to move the nozzle tip to the center of this position. And when I click on this, you should see that it gets pretty close, but it's not perfect. This is just the difference between the default config and what you actually put together, how precise, how many down to how many microns are you actually aligning your staging plate. It's going to be a little different for everybody. So now that I'm at this position and I make sure that I'm at the correct height as well, I'm going to jog the nozzle tip to be perfectly centered over the fiducial. And I'm going to jog it like this too, just to make sure it's dead center. And I'm going to capture this position with this button. This will capture the location that the tool is centered on and populate it into this location right here. So I'm going to select that, and I can see that the X and Y position changed just a little bit, and I can hit apply. All right, so we are in the home stretch now, and we only have a couple steps left before we're ready to run our first job. The next thing we need to set up is the machine vision pipeline for the bottom of the nozzle tips. LumenPnP does this really cool thing where it can actually look at the nozzle tip automatically and figure out where it is and how much run out it has as it rotates. And this makes sure that it's just that much more precise when it places parts. This is actually a vision pipeline that we need to tune. So eventually you'll have to do this for all the nozzle tips that you use, but I recommend starting with N045 and N14 because I find that pretty much everything that I need to pick in place can be done with just those two nozzle tips. So to begin, load your N045 nozzle tip on N1, the left nozzle, and then load N14 onto the right one. So we're going to do just those two to start, but you can do the same process with any nozzle tip. So the first thing we're going to do is we're going to move N1 over to the bottom camera. And we're going to do that by selecting N1, and then under bottom camera, you can just move the nozzle tip to position. And there we go. And now we're going to go under machine setup still. We're going to hit the drop down of nozzle tips, and we're going to select the N045 nozzle tip. Under this setting, you'll see that we have a calibration tab, and this is where this whole runout calibration stuff happens and where all the settings exist for it. You can try and test it and see if it works by just hitting the calibrate button and see if maybe you get lucky and it's pretty close. And this one out of the box is doing a pretty good job of finding that center black dot of the nozzle tip. And there you can see it automatically moves it to the center, which is pretty cool. And it kind of is aware of the offset notable in that nozzle tip. But if it's not quite exactly where it needs to be, you can always hit the edit button on next to pipeline. And this will let you edit the vision pipeline just like we did for the fiducials, but for this step as well. So I'm going to go ahead and hit edit. And just like before, we have a visualization of all of the different stages. So we mask out a circle just like we do before. We have a threshold, and you can see here, this is our threshold image. We have a nice little white dot right there with a good amount of black around it. Blur it out a little bit to make it a little smoother for detection. And then we detect circles, and you can see, sure enough, we find one with a diameter of about 12 millimeters. And when we draw it, it finds it right where it needs to. So this pipeline looks really nicely tuned. So I'm going to exit out of this, and that one's all set. N14 is the next one, so now we're going to click on N14. And you can just click this button if you want to move the nozzle tip to the camera position. So I'm going to hit this. Oh, it doesn't think I have one. That error means that it doesn't think that there's actually a nozzle tip on the nozzle. You can change what nozzle tip the machine thinks it has on each nozzle under these settings here under the reference nozzles. So I just selected N2, and I'm going to select that N14 is loaded. It used to think N08, and I unchecked it. It's going to move the head automatically to a position that makes it easy to exchange these for you. And then I'm going to select N14, and it's going to tell me a manual nozzle tip change is required. That's okay, I just did that, so I'm going to hit OK. And now I am set to go back to my calibration. So I'll click on this button and it moves it over there. And don't worry if it's a little off a little bit. This is what the runout calibration is meant to address. And we're going to do the same thing. We're going to hit edit next to pipeline. And it's not really finding what we want it to find here. So I'm going to go through and figure out what's going wrong. So here we have a masked circle, which masks pretty appropriately around it. We're getting rid of all the extra picture we don't even want to look at. Our threshold looks okay, but I think I actually want to flip it. Now what we want to do is we want to make the thing we're trying to detect look white. And you can see here this center black bit, that actually corresponds with the black part inside of the nozzle tip. So under threshold, I'm actually going to hit the invert button. And this is going to invert the entire picture for us. Now I'm going to go ahead and change my threshold. So I'm going to make it a little bit more stringent. Let's set it to 200 and see what we find. That's the wrong direction. So I'm going to bring it back down to, let's say, 130. All right, might be a little overzealous. I actually think I want to bring it down to very low here and get a nice clean white circle. Look how nice and clean that is to see. Maybe even bring this down to 40. That's a very nice, easy thing to detect right there. So then I'm going to go to blur median, and that's going to blur out all the little pips that are kind of messy. And then we're going to look at detect circles. And you can see here, there's no circles being detected. So I have a suspicion that my diameters are not set correctly. So I'm going to bring this all the way down to 20. I'm going to bring this one to like 150. So we got a nice big wide range. It looks like there, every time you update it, it will actually take a new picture. And there it actually looks a little messy. So I think I was a little too overzealous with my threshold. I'm going to bring this back to, let's say 60, and see if that is more what I want. That looks a little bit cleaner, a little bit more consistent. All right, so here we're drawing a circle, and sure enough, it actually found it there. So it must have been the diameter that was the problem. So I can go in and see that the diameter is actually just about 41. So I'm going to give it a 10 buffer on either side. This is all in pixels, so 10 pixels extra in diameter. So I'm going to set this max diameter to 50 and this one to 30. And we should still see we're getting the picture perfectly. That's great. So now that we have this tuned, I'm going to hit X and I'm going to save my changes, and let's try and calibrate it again. And hopefully it will find what we're looking for. There we go. Very nice. It's finding the center point, and then it should position it to offset that. And there we go. It's perfectly in the center. That's what we're looking for. You might find that sometimes it will be finding the circle, but it will still fail during a nozzle calibration. The way that I address this is I just make the allowed misdetects. I'll bump this up to somewhere around 5, which just gives the machine vision a little bit of a few different extra attempts to try and find the nozzle tip. It doesn't bypass the calibration. It can still fail, but only if it fails 5 times in a row per rotation, because it's doing it on many different rotation positions. So doing this can just help it be a little bit more robust. Finally, we are going to try and home and hope that all of this process all works the way we expect it to. But before we do, we're going to save configuration to make sure that it doesn't get lost with the wind. Now I'm going to hit the home button. The machine's going to move to the front left. And after it finds its front left position, it's going to jog the camera back over the homing fiducial. And we'll see it try and find that there. And sure enough, it's finding that dot pretty good. It's going to do that a few times, and then it's going to move over and do the nozzle tip run out. So let's see how that calibration works. Here's the first nozzle tip. We can see it's finding it just fine. Looks like our calibration looks pretty good there. All right, and it looks like it's finding the N14 pretty well there. Our pipeline is working through it, and there we go. So at this point, we are all perfectly calibrated. OpenPnP knows about all the little offsets that are present in a pick-and-place machine, and now it's time to get it to run its first job.